Alright, this is labeled as problem number 5 on your study guide. I mislabeled it, my bad. So let's go with that. 5A. You're told that this is a telescoping series, which means that things will cancel out. But in order to see what is going to cancel out, we need to expand this fraction. So we need to do a partial fraction expansion, which means we need to take this fraction, 6 over n squared minus 1. We need to factor it. So let's factor that denominator. N squared minus 1 is a difference of squares, which means it can factor as n plus 1 times n minus 1. Now, we're going to expand this into the sum of two fractions by claiming that one denominator can be n plus 1 and another denominator can be n minus 1, each of those factors. Now, we don't know what the numerators are going to be. We're going to say one is a and one is b. And at this stage, it seems like we're working backwards, but we need to actually now find a common denominator and combine these two fractions that we just separated, which seems silly, but you'll see why in a moment, why we're doing that. And so think about the easiest common denominator to get would be that factored bit right there, n plus 1 times n minus 1. So on the left here, I need to multiply by n minus 1. And if I do that in the bottom, I need to do it in the top as well. And on the right here, to get a common denominator, I need to multiply by n plus 1. But if I do it on the bottom, I need to do it on the top as well. And so let's rewrite what we have. I now have a times n minus 1 plus b times n plus 1 all over n plus 1 times n minus 1. And again, the claim with a and b is that this is all still equivalent to this original fraction right here, 6 over n plus 1 times n minus 1. And now, since both of these fractions have the same denominator, we can eliminate them. If you want to think about it as multiplying by that denominator on both sides, that's totally fine. But these numerators must equal each other. So we have 6 equals a times n minus 1 plus b times n plus 1. And now we want to know what are the values of a and b that make this true. But the trick is that this needs to work for all values of n, and so we can be clever about the values of n we choose. Let's choose the value of n where n equals positive 1. Because if we let n equal positive 1 and we rewrite this, we'll have 6 equals a times positive 1 minus 1 plus b times positive 1 plus 1, and that's gone. 1 minus 1 is 0, so my a term disappears. So I chose 1 because that would eliminate my a term. So I'm just left with 6 equals b times 1 plus 1 is 2, and so then b equals 3. All right, let's do the same thing. Let's pick something clever. Let's pick n equals negative 1, because that will cancel out my other term. And when I do so, what do I get? Well, I get 6 equals a times negative 1 minus 1, give myself some room, plus b times negative 1 plus 1, which is 0. So that term is gone, and I'm just left with 6 equals a times negative 1 minus 1 is negative 2. And if I divide by negative 2 on both sides, I get a equals negative 3. So what does this mean? Well, now I can jump back up to this beat right here, looking just at the red stuff, and I know what a and b is, which means I've found my partial fraction expansion. A is negative 3, and b is positive 3. So I'm going to write my b first, since it's positive. 3 over n minus 1. That's that right there, with b plugged in, which we found to be 3. So 3 over n plus 1, and then my a is minus 3 right there. So I'm going to plug minus 3 in for a right there, and I will get minus the 3 over n plus 1 right there. That is my partial fraction expansion, and again, what we're claiming is that this is equivalent to what I started with, 6 over n squared minus 1. Now, if you don't believe me that that actually worked, you should absolutely check this and make sure that it does work. And to check it, all you need to do is find a common denominator here and multiply this stuff back together. So again, if we wanted to do that, I'm going to do it real quick just to convince yourselves that it does indeed work. If I'm finding a common denominator, I need to take this left one, 3 over n minus 1, and I need to multiply it by n plus 1 in the top and the bottom. And I need to take this right one and multiply it by n minus 1 in the top and in the bottom. So now I have a common denominator, which means I can smush them together. And what do I have? Well, in the top, I have 3 times n plus 1. So let's say 3n plus 3. And then I have minus this second numerator, 3 times n minus 1, which is 3n minus 3. Notice I put it in parentheses because I'm subtracting that whole fraction, so you need to remember to distribute that minus over n minus 1 times n plus 1, which n minus 1 times n plus 1 is n squared minus 1 when you factor it. Or rather, when you multiply it all out. N times n is n squared, n times 1 is positive n, negative 1 times n is negative n, those n's cancel. Negative 1 times positive 1 is negative 1. So now let's simplify this a little bit further. 3n plus 3, distribute that minus 3. Whoa, that's a 3, I promise. And 3n minus 3 is plus 3. And so what did I get? Well, 3n minus 3n, those cancel. And this is all still over n squared minus 1. So those 3n's canceled, and I'm left with 3 plus 3 gives me 6 over n squared minus 1. So yes, my partial fraction decomposition or expansion, however you want to call it, did work. That is the same as 6 over n squared minus 1, which means now I can go back to this and say that this will be the same as the summation from n equals 2 up to infinity of that partial fraction expansion, which is this right here. And again, you might not see why that's useful at this point, but hopefully we'll see it in a moment. So 3 over n minus 1, let's say 3 over n minus 1, and then that is minus 3 over n plus 1 right there. And so you still might be looking at this and be like, well, I still don't understand how to do this. We'll plug some stuff in and notice what happens. So when n equals 2, because that's where we're starting, plug in 2 and see what happens. Well, our first term is 3 over 2 minus 1 is 1. Minus my second term there would be 3 over 2 plus 1, which is 3. Okay, well now let's do the next term. Then I'm going to add to that my next term. When n is 3, I'm going to get 3 over 3 minus 1 is 2. And then minus 3 over, when n is 3, 3 over 3 plus 1 is 3/4. And so you're looking at this and you're like, well, I don't get it. Nothing's canceling out. Well, let's keep going. This was n equals 2. This was n equals 3. Let's go on to n equals 4. We need to keep going until we see some stuff actually canceling out. So now we're doing n equals 4. First term is going to be 3 divided by, what is that first term when n is 4? Well, the denominator is 4 minus 1 is 3. Minus that second bit, 3 over 4 plus 1 is 5. Let's go one more. N equals 5. I'm going to get 3 over, I'm doing 5 minus 1 is 4, minus 3 over 5 plus 1 is 6. And for good measure, I'm going to do one more. N equals 6, which will be plus 3 over 6 minus 1 is 5, minus 3 over 6 plus 1 is 7. And I'm going to stop there, and now let's look and see what is crossing off. But look, I have a 3/3 there, and I have a 3/3 there. One's positive, one's negative, so those are gone. What else can we find that matches up? Well, I have a 3/4 there, and I have a negative 3/4 there. Those match up. One's positive, one's negative. Those are gone. And now I have a 3/5 there, and a minus 3/5 there, and those are gone. And if I list my next term would be plus 3 over, if n was 7, I'd get 7 minus 1 is 6. And so that would cancel with that one. And then I'd get minus 3 eighths and nothing cancels, but then if I did the next one, I'd get a positive 3/7, and that would cancel, and then a negative 3/9, and then the next one would give me a positive 3/8, and that would cancel. All of those pieces are canceling out, except for this term right there, and this term right there. So this sum is just 3 plus 3 halves. 3 plus 3 halves is 4 1/2.